Assalamualaikum and hello. Let's continue with the last chapter of this semester where we are going to learn chapter 9, reaction kinetics. There are two subtopics in this chapter and you are going to learn for the first one is rate of reactions and the second one is factors that affect the reaction rate. Let's go to the learning outcomes of this first subtopic where you are going to learn how to define the reaction rate, determine the reaction rate based on experimental data or the graph of concentration versus time, and you need to know how to write the rate expression in terms of differential rate equation or in terms of rate law, and you need to know how to define the order of reaction and determine the reaction rate based on differential equation rate and rate law. And last but not least, you need to know how to determine the order of reaction by initial rate method. So there are a lot of things that we are going to learn in the first subtopic, so I will divide all of this into several videos. Let's focus with the introduction of chemical kinetics. So when we learn about chemical kinetics, what is it about? Actually, we study about the rates of chemical reactions, and there are several factors that affect these rates and the reaction mechanism by which reactions occur. This reaction kinetic is very important for industrial process, for example in terms of time, optimum yield, optimum conditions, or control over reaction, or you need to obtain products economically and using optimum conditions. So these are the importance of chemical kinetics in our industrial process. So what you are going to learn in this chapter, you are going to learn how the reaction rate affects the ongoing chemical reactions. So let's focus with the definition of reaction rate. Reaction rate is the change in concentration of a reactant or product over time. So I highlight the word change and over time because this is very important. So for example, I got A is my reactant to produce my product is B. So what will happen if I want to write the expression for rate? I'm going to write for the reactants and the product as well. So I will write it down, rate equals to negative D concentration A over dt. And as you see, D square bracket A is referring to the change in concentration of A. So the letter D itself is referring to the change. And then you got dt is the change of time or period of time. So this expressions is for reactant. Let's go to the expression for the product. So I will write it as my subject rate equals to positive D square bracket B over dt, just like this one. And as you see here, D square bracket B is referring to the change in concentration of B. As you've learned in the chapter 8 before, you learned about chemical equilibrium, and as we know that when there is a relationship between concentration versus time, we know that the concentration for the reactant will always decrease. However, for the product, it will always increase over the time. So as you see here, my reactant, there is a negative sign for that because concentration of A decreases with time. So that's why the sign for dA is negative. And as you see here, the sign for my product is positive because concentration of B increases over the time. So that's why dB is positive. And you have to know the unit of rate is referring to the expression that you write it down. So as you see here, the top one is the concentration. So usually the concentration, the unit will be mole per liter. And then for time, usually the units will be second. So that's why the units of rate is going to be mole per liter per second, or we can say as molar per second. So that's the general unit for rate. And it can be changed, depends on the question given. The next one, you have to know that reaction rate is inversely proportional to the time. For example, if you want to write it down as the expression rate inversely proportional to 1 over time. And you have to know when the rate increases, the time will decreases. So the shorter the time taken for the reaction to progress, the higher the rate of reaction. That's all for the introduction of reaction rate. In the next video, we are going to focus about how to determine the reaction rate. So I'll see you in the next video. Bye!